like I said, we're doing October-November 2021, paper 1, variant 2. Alright. So, here's the first question. Trigonometric equations. Alright. And the range over here is slightly different than usual. Usually we have from 0 to 360, 0 to 180, but here we have minus 90 to 90. Okay. Now what happens when theta is negative? What's the one change that we do if theta is negative?
So we change the angles on the grid that we make.
Okay.
Like we move anti-clockwise.
Yeah, we move clockwise. Okay. If it's negative, we move clockwise. Normally we move anti-clockwise. So 2 cos theta. So first of all, let's take the LCM. So if you take the LCM, this becomes 7 cos theta minus 3 upon cos theta, and then you cross multiply. So you have 2 cos square theta, okay, minus 7 cos theta plus 3. So I've skipped a couple of steps. I hope you guys know what I'm doing. I've cross multiplied and at the same time shifted 7 cos theta and minus 3 over to the left hand side. Now this is a disguised quadratic equation. You can solve it by using substitution or you can do it directly. I would suggest let's just do it directly to save some time. So I'm going to use a calculator over here. So we have two values of cos theta. One of them is equal to 3, okay, and the other value of cos theta is equal to 1 upon 2. Now which solution should I completely ignore? Cos theta equals to 3 or cos theta equals to half?
Equal to 3, sir.
Why is that?
Sir, it will give no solution, math error.
Okay, I agree, but that's what my question is. Why will it not?
So maximum minimum values mean
yeah, because the maximum value of cos is 1 and the minimum value of cos is minus 1. So anything beyond that, okay, anything beyond 1, anything less than minus 1, there's no point in taking the cos inverse because you'll get a math error, okay. Alright, now here's the tricky part. This is 0, this is 90. Now we can't go beyond 90, alright. So we'll stop there. But we can go in a clockwise direction up until minus 90, okay. And since cos theta is positive, where is that likely to happen? That can happen in the first or the fourth quadrant. So the next thing we're going to do is we're going to find the value of alpha. So for alpha, we're going to do cos inverse of 1 upon 2, which I think is 60. But let's do it. Cos inverse of 1 divided by 2 is 60 degrees. Yep, so alpha equals to 60 degrees. Now that means that we can have 60 degrees with the positive, with the horizontal axis in the first quadrant, or we can have 60 degrees with the horizontal axis in the fourth quadrant. Alright, so what are the values of theta going to be? The first value is pretty straightforward. We're measuring it in an anti-clockwise direction, so it's going to be 60 degrees. What about the other value? What is that going to be?
Minus 60.
Minus 60. Why minus 60? Because we're measuring it in a clockwise direction. So we measure the angle in a clockwise direction like we would measure any other angle, except when we're giving the final answer, we write the minus sign with it. And then just give you an answer in ascending order because it looks nicer that way, although you don't really have to. But yeah, this is good enough. Okay, any questions? Alright, question number 2.
No, sir. Why didn't you take 3 as solution, sir?
Why I didn't take 3 as a solution? Why I ignored this? Is that what you're saying?
Yes, sir.
Okay, so do you recall the graph of cos?
Yes, sir. Yes, sir.
What does it look like?
I do.
What's the maximum value of cos and what's the minimum value?
The maximum value is, sir, minus 1
Minimum, okay.
and minimum value is 0.
No, maximum value is
0.
1
1.
and the minimum value is minus 1. Okay, so is cos theta ever equal to 3?
No, it isn't never. It's never equal to 3. Right,
So
correct.
if you take cos inverse of 3, you get a math error. So that's why we ignored it. I mean, let's say it didn't occur to you that you can't solve this. So even if you tried to solve it, then you will eventually realize it's not possible. Okay.
Sir, what year is this math paper?
This is October-November 2021, paper 12.
Oh.
Okay. Alright, so here's question 2. Question 2 says the graph of y equals to f of x is transformed to the graph of y equals to f of 2x minus 3. Okay. Describe fully the single transformations that have been combined to give the resulting transformation. Alright, so let's start with y equals to f of x. From y equals to f of x to y equals to f of 2x. What do you think has happened over here? It's
It's enlarged.
Yeah, we don't, it's not enlargement, except that we say stretch. Okay, so it's a stretch in which direction? X direction or the Y direction?
X,
In the X direction. Okay, so stretch in the X direction, that's transformation number 1. And what about the stretch factor or the scale factor?
1/2.
1/2. Okay, remember, it's always with X, it's always the opposite. If you're adding something, that means it's moving to the left. If you're subtracting something, that means it's moving to the right. If you're multiplying X by 2, that means that the actual coordinate is getting divided by 2. Okay, alright, so that's the first transformation. What about the second one? When you do y equals to f of 2x plus 3, sorry, minus 3. What does that mean?
So vertical translation.
Yep, it's a vertical translation. And what's
So
the
matrix
translation
0,
matrix?
0 minus 3.
Yep, vertical translation with matrix 0 and minus 3. Okay. Now, part B. Part B says state the coordinates of the points on the original curve y equals to f of x. Sorry, I missed this part. The point P 5, 6 lies on the transformed curve y equals to f of 2x minus 3. Okay, now, it's always a good idea to sort of write down generally what the points would look like after you've transformed them. Okay, so x comma y is the original one. Okay, now what would they look like on the transformed curve? On the transformed curve, x would become x upon 2. Okay, and what would happen to y, considering that it's a translation, vertical translation 3 units down? What would that look like? Y
minus 3.
Y minus 3. Perfect. Okay, this will save you a lot of time. Okay, this will save you from a lot of sort of trial and error, you can say. Now that you know what the transform coordinates are, all you have to do now is just equate them with 5, 6, because 5, 6 are the transformed coordinates. So if you equate them with 5, 6, here's what you get. You get x upon 2, which is equal to 5, cross multiply, you get the value of x, which is equal to 10, and y minus 3 equals to 6, and then you solve this, you get the value of y, which is equal to 9. So previously these coordinates look like 10, 9. There you go. Alright, all good?
So just one question.
Mm-hmm.
So like in the upper part, do we have to like write it in a sentence form, or the way you did, we could like give it in that way?
Just, you don't really have to write it in sentence form, but just make sure that you include everything, okay? Just include the two transformations. Stretch in the x direction, this is what the examiner is looking for. How you write it, that's up to you.
Okay,
But
so
make sure that you don't miss the scale factor, make sure that you don't miss the translation matrix, okay? Or the column vector, whatever you want to call it. Alright?
yes, sir.
And it's obviously important to use the correct terms. We don't say left, right, and all that. We just say it's a vertical translation. Okay, and when we say stretch, don't use horizontal stretch. Write it stretch in the x direction. Okay. All right. So here's question number 3. It says it's functions now. Find the value of f of 5. Yeah, f of 5. Yeah. Sir, how are you all awake at this time? Well, why not? What time do you generally wake up?
So like it's Ramazan, so you don't wake up a bit late, because I thought you kept the class a bit earlier than usual. No?
No. I think last time as well we had it at the same time. No? Actually, I would have kept it late at night, but because of the time difference, you're in Saudi Arabia, right?
Yes, sir.
Yeah, so you're 2 hours behind, and then there are a couple of students from Bangladesh. They're from a different time zone. So because of the time difference, it's very difficult to keep the classes at night. So this is like a win-win for all. So that's why.
Okay, right, sir.
Khair. Anyway, so f of 5. So let's break this down. F of 5 means that first we'll work out f of 5. So f5 equals to 5 plus 3 over 5 minus 1. So 5 plus 3 is 8, 5 minus 1 is 4, so that's equal to 2. Okay. Now we're going to work out f of 2, which means 2 plus 3 over 2 minus 1. So 2 plus 3 is 5, and 2 minus 1 is 1. So 5 upon 1 is 5. And there you go. That's it. That's your answer. So this paper is pretty easy so far, no? What do you guys think?
Yes, sir.
And then we find the inverse, for which
Yes.
we set it equal to y, and we cross multiply, so you have xy minus y, which is equal to x plus 3. Now we get all the x's on one side, so xy minus x equals to 3 plus y. Take x common, you have y minus 1 equals to 3 plus y. X is equals to 3 plus y over y minus 1. And then you do the final step, which is f inverse of x equals to 3 plus x upon x minus 1. And there you go. That's it. That's your answer. Sir, why did you solve for f of 2? Okay. So basically, f of 5. Okay, such a tongue twister that is. So first we evaluated this part of the function. Okay. And what did that turn out to be? That turned out to be 2. So I'll write it over here, that f of 5 is equal to what? Is equal to 2. So now we replaced f of 5 with 2. Okay, and then we evaluated that. That's how we ended up with 5. Okay. Alright, great. Then comes question number 4. So it says a curve is such that dy by dx is so and so. The curve passes through the point. Find the equation of the curve. Okay, so this is finally a challenging question. How do you find it out? So from dy by dx, how do you find out the equation of the curve? What do you do?
Integrate, sir.
Yep, you integrate dy by dx to find out the equation of the curve. Now we can't integrate this the way it is, so first we'll have to make it sort of integration ready. So 8 3x plus 2, we're moving it in the numerator, so the power becomes minus 2. And now when we integrate it, we get y equals to 8 3x plus 2 as it is, you add 1 to the power, so that's minus 1, divide by the new power, so that's minus 1, and also divide by the differential of the bracket 3x plus 2, which is going to be 3. Okay, and then don't forget the plus c. So let's write this nicely. Y equals to, so this will become minus 8 over 3 into 3x plus 2. Okay, let me just double check. Yeah, you can expand, you can open the bracket since the power is 1. Okay, but either way you eventually have to plug in these two values. So in place of x we plug in 2, and 5 into 3 is 15, 15 plus 2 is 17, so 17 upon 3 goes in place of y. So 17 upon 3 equals to minus 8. 3 into 2 is 6, 6 plus 2 is 8, 8 into 3 is 24. So minus 8 upon 24 plus c. And here we have 17 upon 3. In fact, let's just use a calculator, save some time, and write down the value of c directly. So c is going to be 17 upon 3 plus 8 upon 24. So we're looking at 6. And there
Sir,
you go. Yeah.
I guess, sir, you forgot to put the minus sign on
Where?
negative 3.
Okay, so I moved the minus in the numerator. Alright, I could have kept it in the denominator as well, but I moved it in the numerator, since that's how you normally write a function.
No, I didn't see the numerator sign, sorry.
Alright, nothing to worry about. Okay, so there you go. The final equation is minus 8 over 3 into 3x plus 2 plus 6. Okay, and then it's up to you if you want to leave the denominator as it is or if you want to expand it further. Okay, so any questions so far?
No, sir.
Alright, now, okay, this by the looks of it seems like a tricky question, so let's see. It says, especially when you have APGP sort of mixing up with trigonometry, you know things are about to get difficult. Alright, I'm not trying to like demotivate you guys or something. Trigonometry mixed up with with anything, in fact, can be tricky. Okay, so let's see. The first, third, and fifth term of an arithmetic progression are 2 cos x minus 6/3 sin x and 10 cos x. Okay, respectively, where x is between half to pi. Okay, so this is probably going to help us when we're solving a trigonometric equation, so we would know what solution to take and what not to take. Okay, so these are alternate terms. Okay, they're not the first, second, third term, they're actually the first, third, and fifth terms. Okay, so that's interesting. You have 2 cos x comma minus 6 under root 3 sin x and 10 cos x. So what can you tell me about these three terms other than the fact that they're in an arithmetic progression? There's something else about the terms that's going to be the same. So in fact, to make life easy, let me write down another arithmetic progression, okay? 3, 5, 7, 9, 11, 13. Okay, and focus
common
on
difference.
yes, focus on the first, third, and fifth term. Can you repeat that? Try what you said.
They are all prime numbers.
Okay, well, that's a good observation, but that was not the observation that I was trying to make you guys make. There's something else to observe over here.
So a common difference.
Common difference, okay? Now, although with consecutive terms, the difference is common, but with alternate terms, the difference is also common, right? Because if, let's say, the difference between consecutive terms is 2, like it is in this case. So the difference between alternating terms, like for example first and third, third and fifth, that would be double of that, okay? But what's important is that it's going to be the same, okay? So what that means is that T3 minus T1 is actually going to be equal to T5 minus T3, okay? Now before I solve it any further, once you have an equation, then it becomes easier, but before I solve it any further, I want to make sure that you guys understand what I've done over here. So if you don't, feel free to ask.
Sir, how are you able to tell that the common difference was the same between consecutive terms?
Okay, so first of all, it's an arithmetic progression, alright? What do we know about arithmetic progression? We know that the difference between consecutive terms is the same, alright? What we know is that the difference between consecutive terms is the same. But what if we don't take the consecutive terms, but like we skip one term in the middle? So for example, if let's say you take the first and then you take the third term, and then you take the third and then you take the fifth term, what do you think the difference will be in these two terms? It will be the same.
Yeah.
Okay, like for example, write down any arithmetic progression, okay? Any arithmetic progression with any common difference whatsoever. Okay, let's say 10, 14, 18, 22, 26, plus 4, plus 4, plus 4. Yeah, okay. Now, notice that the difference between the first, between any consecutive terms is the same. Alright, but ये तो है ही ना, मतलब ये तो जाहिर सी बातें होना ही है because it's an arithmetic progression, okay? But not only that, if you take the difference between the first and the third term, and at the same time if you take the difference between the third and the fifth term, okay? Because they're in the sort of, these terms are in a sequence, 1, 3, 5, the difference between them will also be the same. Okay, so if you find out the difference between the first and the third term, you'll notice that's 8. If you find out the difference between the third and the fifth term, you'll notice that's 8 as well. Okay?
Okay.
Alright, now, so let's calculate the difference. That means minus 6 under root 3 sine x minus 2 cos x. Okay, so that's the difference between the third, no, wait a minute. Yeah, so that's the difference between the third and the first
We don't
term.
have the first term.
Sorry?
Yes, we have the first term, sorry.
Yeah, we have the first, third, and fifth. Okay, so here you can see I've taken the difference between the third and the first term. So that's minus 6 under root 3 sine x minus 2 cos x. Okay, and this, as we know, is going to be equal to 10 cos x. Now be careful over here. Minus 6 under root 3 sine x. Now where do you think we're heading over here? Okay, we'll solve this, we'll simplify it, no big deal. But where do you think we're heading? Where do you think we're headed over here? What exactly?
tan की form में जाएंगे.
Yes. So basically we're heading towards a trigonometric equation. Okay. So it's good to keep that in mind so that you know you're able to anticipate better. So minus 6 under root 3 sine x minus 2 cos x is equals to 10 plus 6 under root 3 sine x. So let's see what we can, oh, I forgot to write cos x with 10 cos x. Okay, now we'll have to get all the sine x on one side and all the cos x's on one side. So minus 6 root 3 sine x plus, no, not plus, minus 6 under root 3 sine x equals to 10 cos x plus 2 cos x. Okay, so here's what I've done. I've taken 6 root 3 sine x over to the left hand side and minus 2 cos x over to the right hand side. So here's what I'm looking at. I'm looking at minus 12 root 3 sine x equals to 12 cos x. Okay, now sine x upon cos x is equals to 12 upon minus 12 under root 3. Okay, if you simplify this, this is what you're looking at. Sine x upon cos x is equal to minus 1 upon under root 3. Okay, if you simplify this using your calculator. Now, this becomes tan x. So tan x is equal to minus 1 upon under root 3. So what are we looking at? We're looking at a trigonometric equation which we're going to solve now. Okay, so tan x is negative. Where does that happen? Where is tan x negative? In what?
So second and fourth.
In the second and fourth. That's correct. Okay, so and make sure that you convert your calculator into radian mode before you do anything else. So this is where we'll find alpha. So here's 0, here's pi upon 2, here's pi. But the thing is, we're not going to go beyond the second quadrant. In fact, we will remain in the second quadrant only. Why? Because if you look at the range, it's from pi upon 2 to pi. So that means we're only going to take this solution. Okay, we're not going to take the other solution. So let's find out the value of alpha. So for alpha, we'll take, well, first of all, you convert your calculator into radian mode. So I've just done that. Then we will take the tan inverse of 1 divided by under root 3. Remember, when you're calculating alpha, you ignore the minus sign. So we're looking at 1 upon 6 pi. So what will the value of x be? The value of x will be pi minus 1 upon 6 pi. And what's pi minus 1 upon 6 pi? It's equal to 5 upon 6 pi. So there you go. That's it. That's your answer. Now, take a good look at what I've done. Let me know if you have any questions. This was a tricky question. I think the first tricky question of the paper so far. Then the question says, hence find the exact sum of the first 25 terms of the progression. Okay, so first of all, let's write down the formula. When you write down the formula, you'll know exactly what it is that you need in order to be able to find out what the question wants you to find out. So n upon 2 into 2a plus n minus 1 into t. Okay, we know that n is going to be equal to 25. Why? Because we want the sum of the first 25 terms. So we'll write n over here as 25. So this is what we're looking at. We're looking at S25 to be equal to n upon 25 upon 2. Okay, now can we find out the value of a if needed? We can find out the value of a because we know that the first term is 2 cos x. Now we can find out what a is going to be by simply doing 2 cos 5 upon 6 pi. So let's evaluate a and make sure to give your answer in exact form. So 2 cos pi upon 6, 5 pi upon 6. So we're looking at minus under root 3. So a is minus under root 3. Now the question is, how will I find out the common difference? So basically, the common difference, I was supposed to take this. This or this. Doesn't matter which one you take. Okay, so let's take this one. So basically, the difference between these two and the difference between these two will be the same. Alright? The first thing. And then, the difference will actually not be equal to the common difference. The difference will be double of the common difference. Why? Because if you remember the example that I gave here, 3, 5, 7, 9, 11. 1, 2, 3, 4, 5. Okay. So the common difference of this arithmetic progression is 2. But if you take the common difference between the first and the third term, that's going to be 4. And then if you take the difference between the third and the fifth term, that's going to be 4 as well. And 4 is, as you can see, double of 2. So if you're calculating the difference between the first and the third term, that, remember, will not be your actual difference. That will be double of the difference. Okay? Do you get it? Do you understand this part now?
So
Okay. So the mistake that I made over here was that I actually took the simplified version. Okay? Now the simplified version obviously is not equal to the common difference. It's either this, the one that I've circled here, or this that's going to be equal to the double of the common difference. So let's go back and fix this. So 6, in fact minus 6 under root 3 sine of 5 upon 6 pi, okay, whatever that is equal to, minus 2 cos 5 upon 6 pi. And then in the end, don't forget to divide this by 2. Okay, so let's work this out. Minus 6 under root 3 sine 5 upon 6 pi. So 5 pi upon 6, close the bracket. So we're looking at minus 3 under root 3. Okay, minus 2 cos 5 upon 6 pi. So we're looking at positive under root 3. Okay, and then when you divide it by 2, here's what you get. The common difference is equal to minus under root 3. So minus 3 under root 3 plus under root 3 divided by 3. So the common difference is minus under root 3. So the common difference is actually the same as the first term, okay, which is a coincidence. Now, 2a plus n minus 1 means 24 into the common difference, which as we just saw is minus under root 3. Now this is what we're going to simplify. So this becomes minus 2 under root 3 minus 24 under root 3, which we're going to multiply by 12.5 to find out the sum of the first 25 terms. So minus 24 minus 2, minus 24 minus 2 into 12.5 gives us minus 325 under root 3. Minus 325 under root 3. Okay, let me just double check if that's the correct answer. Question number 5 part B. Yeah, that's the correct answer. Okay, now take a good look at what I've done. Let me know if you guys have any questions.
So when you were finding D, did you multiply by 2 or divide by 2?
Divide by 2. Okay, I forgot to write divide. Okay.
So did you redo the question?
Sorry?
Did you redo the question?
Yeah, I did,
Like,
because there was a mistake in the common difference. Okay, so the common difference will basically be calculated by either plugging in the value of x in here or in here, but I accidentally plugged it in over here in the simplified version, which obviously is not equal to the difference. Why did you get disconnected?
No, sir. Actually, I was looking at another question and I didn't realize that you were doing this one again.
Oh, okay. Okay. So question number 6 is of GP. So it says the second term of a geometric progression is 54. Okay, and the sum to infinity of the progression is 243. The common ratio is greater than half, so this probably means that we'll get two answers. One of them would be greater than half, and that's the answer that we're going to go with. Okay, find the 10th term, giving your answer in the exact form. Okay, so the second term basically means, so the second term is equal to 54, and the sum to infinity is equal to 243. So let's not waste any space, so I'll drag this here. The second term basically means AR, that's 54, and sum to infinity basically means A over 1 minus R, which is equal to 243. So clearly we can solve these two equations simultaneously to find out what we need. So you can make A the subject. So if you make A the subject, that's going to be 54 upon R, and then if you plug it in over here, 54 upon R divided by 1 minus R is equals to 243. So this means 54 upon R into 1 upon 1 minus R is equals to 243. Okay, make sure to use the space efficiently. Now the denominator looks like this, 54 over 1 minus R square equals to 243, and then if you cross multiply, this is what you're looking at. 54 equals to 243, sorry, R minus R square, 243R minus 243R square. Okay, now let's shift everything over to the left hand side so that the term with R square is positive. So 243R square minus 243R plus 54 equals to 0. Now 243 is divisible by 9 and 54 is also divisible by 9. Now if you want, you can take 9 common to make life easy. Okay, in fact you can do better than that. 243 is a multiple of 270. Let me check. 243 divided by 27. Yeah, so you can actually take 27 common if you want, but so let's take 27 common. So we have 9R square minus 9R plus 2 equals to 0. So this equation we can solve through middle term breaking. Okay, but I'm going to use the calculator to save some time. So we're looking at 9 minus 9 and 2. So one value of R is 2 upon 3 and the other value of R is equal to 1 upon 3. Now which value are we going to take? Are we going to take 2 upon 3 or 1 upon 3?
2 upon 3.
2 upon 3. Why?
1 upon 2 upon 3. Sorry.
2 upon 3. Why? Because it has to be greater
Because
than
greater than 1 upon 2.
1 upon 2. Okay, 2 upon 3 is sorry, we will take 2 upon 3, we'll reject 1 upon 3. 1 upon 3 is 0.33, which is clearly not greater than 0.5. Okay, so now that we have the common ratio, now remember what we have to find. We have to find out the 10th term, and the 10th term is basically equal to AR power n minus 1, which means AR power 9. So we still need the value of A. Now we can find out the value of A. It's pretty easy. A is equal to 54 upon R.
54.
Yeah, 54 upon R. So A is equals to 54 divided by 2 upon 3. So let's use a calculator over here. 54 divided by 2 upon 3. So we're looking at 81. Okay. Now that we have everything, all we have to do now is just plug it in. So 81 into R, which is 2 upon 3 to the power of 9. Now I don't expect the calculator to give me the exact answer. 2 upon 3 to the power 9. Okay, not bad. We are getting the exact answer. So the exact answer is 512 upon 243, which is your 10th term. Okay. If let's say the calculator didn't give the exact answer, then we would have rewritten 81 as a power of 3. Okay. And then simplified it with 3 power 9. And 2 power 9 is something you can evaluate in your calculator. It will definitely give you the exact answer. But that is if your calculator didn't give the exact answer of this 2 upon 3 whole thing to the power 9. Then you would have had to do it manually, use rules of indices to simplify. Okay. Now, any questions so far? Anything that's not clear, please feel free to ask.
No, sir, nothing at all.
Alright, so I think we're done with 50% of the paper. How many questions do we have?
Sir, I have a question.
Go ahead.
So why do you reject the 1 upon 3 value?
So the question said at the very beginning that the common ratio is greater than 1 upon 2. Okay, so if you look at the two values of R that we're getting, which one is greater than 1 upon 2? It's 2 upon 3. Okay?
Oh.
Alright, now here's question 7. Question 7 says, in the diagram, circular measure by the way. In the diagram, the lengths of AB and AC are both 15. So that means we're looking at an isosceles triangle, perhaps even an equilateral triangle. We'll find that out later. In fact, I'm pretty sure it's not an equilateral triangle actually. The point P is the foot of the perpendicular from C to AB. Okay. The length CP is 9. Alright. An arc of a circle with center B passes through C and meets AB at Q. Okay. An arc of a circle, center B, so that's this arc the question's talking about, passes through C and meets AB at Q. Okay, so it's passing through C and it meets AB at Q. Okay. Show that angle ABC is equal to 1.25 radians. Correct to 3 significant figures. Okay. Let's see how we can do this. So we have a triangle of which we know 2 sides. Okay. And we know the perpendicular side as well. So we can do it through the area, half into base into height, or we can do it through Pythagoras. Can we use Pythagoras over here?
Then actually we can also use the sine rule.
Yeah, we can use
sine, like
sine rule. How does sine rule fit
find
over
A
here?
basically. Sir, to find A we can use the sine rule, and then we know that this is an isosceles triangle, so we can just find B, the angle B. No?
Okay. How about
Let's say angle AC is equal to 50, like the length AC is equal to 50 centimeter and PC is equal to 9 centimeters. So we can use sine 9 over 15.
But that will give us this angle. Yeah, you're right. That will give us this angle, and then we can subtract that and divide by 2. Why? Because this angle will be equal to this angle. Yeah, is that what you're saying?
Exactly right, sir.
Perfect. Okay. Alright, so let's do that. Let's first find out this angle for which we have the opposite side, okay, and we have the hypotenuse side. So what trigonometric ratio are we going to use over here? We can use sine, or we can actually use sine rule as well, okay. So sine of BAC is equals to opposite, which is 9 over 15. That's the hypotenuse. So make sure your calculator is still in radian mode, okay. So sine inverse of 9 divided by 15 gives you 0.643. So 0.643. Now, in order to find out angle ABC, so for ABC, here's what we're going to do. We're going to do pi, which is equal to 180, and from pi we're going to subtract 0.643, and then we're going to divide it by 2. Why? Because these two, since it's an isosceles triangle, these two angles are going to be equal. So if you do that right, here's what you get. You get ABC is equal to 1.249, which if you round off correct to 3 significant figures, you get 1.25 radian. Okay. Now, part B. Part B says, calculate the area of the shaded region which is bounded by the arc CQ and the lines CP and PQ. Okay, so before we do anything else, let's take a screenshot of this and bring it over here. Okay, now, so we have to calculate the area of shaded region. Let's see what we can do in order to calculate the area of the shaded region. Okay, let's try and come up with a rough equation. Okay, so what equation do you guys suggest that I can use to calculate the area of the shaded region?
Sir, the one thing I think is that we can solve the sector area, and
good.
then after that minus the area of the triangle.
Sector
PVC.
minus the area of triangle. Which triangle are we talking about over here?
PVC.
Yep, we're talking about PVC. Okay, so that's the equation. The shaded area is equal to area of sector, okay, minus the area of triangle. Okay, perfect. Now, thankfully, the question has made us okay. No, we don't have enough information, so we will have to figure something out. So we do have this angle, okay. Now this angle is 1.25. Now if I want to calculate the area of the shaded region, that means if I want to calculate the area of sector, so either I need the arc length, okay, or I need the radius. So if we're talking about area of sector as we know is equal to half r squared theta. Okay, so we have theta, we don't have the radius. Yeah, go ahead.
You can find BC by the sine rule.
Yep, I can find BC by using sine rule, or I can find BC using sine rule. So sine of 1.25 equals to opposite, which is 9, over hypotenuse, which is BC. Now let's work this out. So that's going to be 9 divided by sine 1.25. So we're looking at 9.48. Okay, 9.48 centimeter. Okay, so if this is 9.48, so that is basically equivalent to the radius of the sector. So now we can find out the area of sector. A of sector is equal to half into r squared, which means 9.48 squared, into theta, which means 1.25. Okay, so 9.48 in squared into 1.25 divided by 2. So we're looking at 56.25. Okay, 56.25 is the area of sector. Alright, now from this we're going to do what? From this we need to subtract the area of triangle. Alright, so let's find that out. Let's find the area of triangle. And what triangle are we talking about? We're strictly talking about PBC. PBC. Now, do we have enough information to do that? We kind of do, and at the same time we also kind of don't. Okay. So since we know that BC is 9.48, what other length do you think will also be equal to 9.48? Take a closer look.
The one thing we can do is half into sin C, find third angle C.
Yeah, okay, we could do that. Now I'll tell you what I was thinking, so you guys know that you have multiple options. What I was thinking was that since BC is equal to 9.48, what do you think about BQ? What is this going to be equal to? This will also be equal to 9.48 since it's the radius of the sector, yes. And then we can find out this length by simply subtracting it from 15. Okay, but again, what you're saying is also perfectly alright, okay? But just be aware that you have multiple
how
options.
will you won't be able to get that length if you minus it from 15. So won't you get AQ?
Oh yeah, you're right. We will get AQ. Okay. Yeah. You're right. Okay.
So can't you just use trigonometry?
Yes, let's use that. Let's ditch this. Okay, you're right. Thank you for pointing that out. So let's find out. So since we have 9.48 and 9, let's find out the third angle, for which we will do pi minus the sum of the other two angles, which means pi upon 2 plus 1.25. Okay, so let's do that. Pi minus pi upon 2 minus 1.25. So we're looking at 0.321. So this angle is angle PCB is equal to 0.321. So here's what we're going to do. Half into 9 into 9.48 into sine of 0.321. Okay, so let's do that. Into 9 into 9.48 into 0.5. So we're looking at 13.45. So 13.45 or 13.5. In fact, it's not, since it's not the final answer, let's just not round it off. 13.45 centimeter square, the area of triangle. Now for the final answer, we do 56.25, and from it we subtract 13.45. Let's see what do we get. 56.25 minus the answer. So we're looking at 42.79, which becomes 42.8 centimeter square. And there you go. That's it. That's your final answer. Okay, now, any questions? Here's all the working. Okay, great. Question number 8, binomial. Okay, so what's the only thing that hasn't been tested so far? Integration, area under the curve. No, wait, we have been tested on integration. Differentiation hasn't been tested. Okay, so that means the next question could be of differentiation, and of course coordinate geometry, equation of circles. Yeah, just saw that as well. Okay, so it says it is given that in the expansion of 4 plus 2x into 2 minus ax to the power 5, the coefficient of x square is minus 15. Okay, so how will I get the coefficient of x square if I'm multiplying these two? 4 plus 2x into 2 minus ax to the power 5. How many up until what term should I expand this?
2.
The first two terms? Are you sure about that?
Like 1, I guess, sir, we should start from 2 and 3. Like 5c2, because sir, 5c1, I guess we will have a single value, like a single value in sense independent of x.
No, 5c0 will give us independent of x. Okay.
Yes,
See,
yes,
x is in the second term.
5c1 and 5c2.
Yeah. So we will plug in r as 1 and r as 2. So we have the coefficient of x and the coefficient of x square. Now, why do we want the coefficient of x and x square? Because what we want at the end is the coefficient of x square only. So if let's say we have a term with x and a term with x square, so 4 will get multiplied by the term with x square and 2x will get multiplied by the term with x, and that's how we'll end up with the coefficient of x square at the end. So let's expand this. Let's start with 5c1, 2 to the power 5 minus 1, which is 4, and minus ax to the power 1. Okay, let's evaluate this. So 5c1 is 5, 2 power 4 is 16, 5 into 4 is 16. Oh, sorry, 5 into 16 is 80. So we get minus 80 a power a into x. Why minus? Because of the minus over here. Now let's evaluate 5c2, 2 to the power 3 minus ax to the power of 2. So 5c2 is 10. 5c2 is 10. Let me double check. 5c2 is 10 into 8. So that's 80. Except that this time we'll have a square x square. Okay, do not forget that there will be a square on a as well and not just x. So now we know what to multiply 4 plus 2x with. We're going to multiply it with minus 80ax and positive 80a square x square. So 4, when you multiply it by positive 80a square x square, so 8 into 4 is 320. Okay, 32 and then 320. So 320a square x square. I'll just write down the answer directly. Okay. Minus, why minus? Because 2x gets multiplied by minus 80ax, so that gives us minus 160 a x square. Okay, now let's scrape off just the coefficient, so that means taking x square common, so we have 320a square minus 160a. Okay, and this according to the question is equal to what? this, according to the question, is equal to 15, minus 15 actually. Okay, so we make a quadratic equation out of it. I'm pretty sure the question has given a condition on A, or maybe it's asking us to find the possible values. Okay, so since it's asking us for the possible values, that means when we solve this, we're likely to get two answers and we need to give both of them. So 320 minus 160 and 15. So one value of A is equals to 3 upon 8 and the other value of A is equals to 1 upon 8. And there you go. That's the answer. Now, any questions? If yes, feel free.
Why
to
you
ask.
take R as 1?
Because we want the coefficient of x and we want the coefficient of x square. And why do we want the coefficient of x and x square? Because whatever this expansion is, this expansion needs to be multiplied by 4 plus 2x first before we give the coefficient of x square. So 4, if you multiply it by the coefficient of x square, gives you the term with x square, like we did over here. 4 got multiplied by 80 a square x square. And what should we multiply this 2x with? So that we get x square at the end. Think about it.
Minus x.
Yeah, we need to multiply it by x.
X1.
X basically, whatever the coefficient of x is. Okay, does that help?
Yes, sir.
Alright, great. Okay, now we're done with 8 part A. Let's see what part B is. Part B says it is given that instead that in the expansion 4 plus 2x into 2 minus ax to the power 5, the coefficient of x square is k. It is also given that there is only one value of a which leads to this value of k. Okay, so now the question has all of a sudden taken a turn. From binomial, it's gone to something else. Anyone who can tell me what the question is talking about over here? Let me write this down first. 320a square minus 160a equals to k. Okay, now let's write this nicely. 320a square minus 160a minus k equals to 0.
Simultaneous equation.
No, not simultaneous equation.
Sir, b squared minus 4ac.
Yes. So basically, think of it this way. The question here is now kind of trying to tell you that it is also given that there is only one value of a which leads to this value of k. Okay, that means the question is trying to tell you that this equation basically has only one solution. Okay, now how does an equation have only one solution? It has one solution when the discriminant is equal to 0. See, this is a quadratic equation. K is a constant, alright, and the unknown in the quadratic equation is a, which is normally x. So if the question said that there is only one solution to this equation, that means b square minus 4ac equals to 0. What kind of an equation has only one solution? The one which has discriminant 0. So if there is only one value of a, now a is what we would get when we solve this equation. Now having only one value of a means that we have only one solution to this equation. And having one solution to this equation means that b square minus 4ac is actually what? Is actually equal to 0. Okay, now let's first scrape off the values of a, b and c. A is 320, b is minus 160 and c is minus k. So b square means minus 160 squared minus 4 into a, which is 320, into minus k equals to what? Equals to 0. Now minus 160 square is what? 256. Yeah, minus 25,600, positive 25,600. So 25,600, this would become plus 4 into 320 is equal to 1280k equals to 0. That means 1280k equals to what? Equals to minus 25,600, which means k is equals to minus 25,600 divided by k, which is equal to minus 20. Now this is only the value of k. We still have to find out the value of a. So how do you suggest I find out the value of a? Now that we have the value of k, how do I find out the value of a?
Quadratic equation.
Yeah, so I plug this value of k which back into the equation, okay, equals to minus 20. 320a square minus 160a plus 20 equals to 0. Now this is a quadratic equation. How many solutions do you think I will get when I solve this quadratic equation? Will I get two solutions?
Two solutions, sir.
Okay, think
Maybe
about
one can be 0.
Will I get two solutions or will I get one solution? Think about it.
So you will get one solution because
I will
one
get
solution
one
will be
solution.
0.
Yes, why will I get one solution? Because it is this value of k that will give us only one solution. Okay, remember, what we have done is, we have set the situation such so that we only get one solution. Why? When we set the discriminant equal to 0 and we solve for the value of k or whatever it is that you're solving it for, that means that value will give you only one solution. Now when you plug in that value back into the equation to solve for the actual solution of the equation, you will get one. So you should get one solution if your value of k is correct. Okay, so for example, if I solve this, okay, again I'm just going to use the calculator over here to save some time. So if you solve this, ideally I should get only one solution. So one value of a is 1 upon 4, the other value of a is also 1 upon 4. Okay, so that means there's only one solution. And there you go. Here's the value of k, and here's the value, here's the value of a, and here's the value of k. There you go. Now, so quadratics has also been tested. Quadratics ho gaya, functions, well, that was not like a thorough function question, so you can expect functions later on. But for sure, area, when it comes to integration, that is left, differentiation is left, and like we saw, coordinate geometry is also left. Okay, so any questions? Yes, no? Okay, great. Now here's question 9. Let's see what question 9 says. Question 9 says the volume V meter cube of a large circular mound of iron ore is R meter modeled by the equation V equals to so and so. Iron ore is added at a constant rate of 1.5 meter cube per second. Okay, so what does 1.5 meter cube per second mean? What is this? What exactly are we given when it says 1.5 meter cube per second? Change in what exactly?
Volume.
Change in volume, very good. With respect to?
Time.
With respect to time, that's correct. Okay, so that means dV upon dt is equals to 1.5 meter cube. In fact, there's no need to write meter cube, just write 1.5, that's good enough. Okay, now let's see what the question says. Find the rate at which the radius of the mound is increasing at the instant when the radius is 5.5. So we want to find out dr by dt when r equals to 5.5. So the first thing you want to do is, before you do anything else, you want to make a chain rule over here so that you know exactly what it is that you have already and what it is that you need to find out in order to calculate dr by dt. So let's establish a chain rule over here. Dr by dt will obviously be found by multiplying two fractions. Okay, now one thing we can say for sure is that the numerator of the first fraction will be dr and the denominator of the second fraction will be dt. Okay, now what would go over here and over here? And it obviously has to be relevant. Okay, like for example, you can't plug in a over here. What do you think will go over here?
So dr upon dv.
dr upon dv. Yep, dv will go over here basically. So we'll have dv here and we'll have dv over here. Okay, now the thing is, as far as dv upon dt goes, we have that. It's nothing to worry about. But how do I find out dr by dv? Read the question and tell me how I can find out.
Differentiate.
Yes, that is true. I will differentiate it. Achha. Now when I differentiate it, we hit another problem. You end up with dv upon dr. So first let me differentiate it and then you guys can tell me how we're going to fix this. So 9 upon 2 into r minus 1 upon 2 to the power of 2, and then if you multiply it by the differential of the bracket, that's going to be 1. Okay, so how do I fix this? We have dv upon dr. I can plug in the value of r in this. Okay, r is 5.5. So 9 upon 2 into 5.5 minus half is 5, so that's 5 squared. So dv upon dr is basically equal to 25 into 9 divided by 2. 25 into 9 divided by 2. So we're looking at 112.5. So this is dv upon dr. How do I change this to dr upon dv?
One over.
Reciprocate it.
Yep.
So why you need to change it?
Because in the chain rule, what do we have? We have dr upon dv. Okay, and what we have found is dv upon dr. Get it? It's like cross multiplying.
Don't you have to reciprocate it?
Yeah, we have to reciprocate it. That's what I'm saying. Okay, so dr upon dv will become what? Dr upon dv will become 1 upon 112.5. So 1 upon 112.5 into dv upon dt, which the question told us is 1.5. Okay, so now all you have to do is just evaluate this. So dr upon dt is equal to, let's see, 1 divided by 112.5 into 1.5. So we're looking at 1 upon 75, which I wouldn't recommend that you write it as decimal because it's a recurring decimal. So we'll leave it as 1 upon 75. Since it's radius with respect to time, so centimeter per second. Okay. Meter per second actually. Just realized it's meter. So there you go. That's it. That's your answer. Now, let me know if you guys have any questions, and let me know if this confusion is now clear, that why we turned dv upon dr to dr upon dv. Okay, no questions, I'm assuming. Part B. Find the volume at the instant when the radius is increasing at 0.1 meter per second. Okay, so now we're given the rate of change of radius, which is dr upon dt, and that's 0.1. Okay, and we need to find out the actual volume, not the difference in volume. We need to find out the actual volume. Okay, so volume, as we know, is equal to what? Is equal to 3 upon 2 into r minus 1 upon 2 cubed. Okay, so let's write down the formula. 3 upon 2 into r minus 1 upon 2 cubed. Okay, so let's put this on the side for now. Okay, now the question is, how will I find out the value of r if, let's say, I'm given dr upon dt? Question for you guys. Anyone? Think about it. So I'll paste the question over here as well.
So what was the question again?
My question is, well, just tell me how we're going to do this question. That's what the question is.
Sir, we will also take dv over dr.
Okay. And then
dr over dv. Like we may make dr over dv is equal to something
yes. Okay, so you're kind of on the right track. So basically the objective is to find out the value of r. Once we have the value of r, things will work out for us, right? So now the question is, how do I find out the value of r? Now, so this we'll have to sort of reverse engineer. Okay, so if you're given dr by dt, as we know, can be worked out through this formula. Okay, through dv upon dt over here and dr upon dv. Okay, now dr upon dv is something that we know already. Okay, I mean, we know the expression for it. Why? Because dv upon dr, we worked it out, that was equal to what? That was equal to 9 upon 2. So 9 upon 2 into r minus 1 upon 2 squared. R minus 1 upon 2 squared. Okay, so dr upon dt is 0.1. Okay, this is equal to dr upon dv into dv upon dt. So what's dv upon dt? That's 1.5. dv upon dt is 1.5. Okay, so that means I can replace this with 1.5. Now this will allow me to find out the value of dr upon dv. How? All I have to do is take 1.5 over to the other side, so 0.1 divided by 1.5 gives me the value of dr upon dv. So let's work this out. 0.1 divided by 1.5 gives me 1 upon 15. So if 1 upon 15 is the value of dr upon dv, what do you think dv upon dr will be equal to? What will dr upon dv be equal to, given that dr 15? Perfect. Now this 15 I can replace over here. Okay, 15 equals to 9 upon 2 into r minus 1 upon 2, the whole thing square. Now let's take 9 over 2 to the other side. So 15 into 2 divided by 9. So what we're looking at is, we're looking at 10 upon 3 equals to r minus 1 upon 2, the whole thing square. Now how will I get rid of the square? We'll have to take the square root on both sides. And remember, all of this is to just find out the value of r. And once we have the value of r, that will not be the end of the question. We still have to find out the volume. That means we'll plug in that value of r back into the original equation. So this is what we're looking at. 10 upon 3 inside the square root equals to r minus half. So r equals to 10 upon 3 inside the square root plus 1 upon 2. So let's work this out. 10 upon 3. So square root of 10 upon 3. 10 upon 3 plus 1 upon 2. So what we're looking at is the value of r, which is 2.3257. Again, since this is not the final answer, I've taken it, I've not rounded it off. Now we're going to find out the volume, which as we saw is equal to 3 upon 2 into 2.3257 minus 1 upon 2, the whole thing cubed. So just use your calculator over here. Okay, first work out this portion, and then let's cube it into 3 divided by
minus 1 also.
Sorry?
Minus 1. The v equals 3 upon 2 and then minus 1. Just add minus 1 after. Yeah.
Can you repeat that?
Okay, so v equals 3 over 2 and then the whole thing cube, then you add minus 1 because it's written.
Oh, okay. Oh yeah, you're right. Okay, so thankfully we got away with it when we were differentiating it, because the differential of minus 1 would have been 0. Okay, so got lucky once, couldn't get lucky twice. So v equals to what? V equals to 8.1287. So we'll lock it at 1.83 centimeter cube. Okay, thank you for centimeter cube, actually meter cube. So thank you for pointing that out. Okay, so there you go. That's it. That's your answer. Now, any questions?
सर मैंने पूछना था कि उसने इसमें बोला है रेट ऑफ मतलब रेडियस इज इंक्रीजिंग, तो सर अगर वो डिक्रीजिंग कह दे तो इज इट लाइक वैल्यू माइनस हो जाती है?
माइनस हो जाएगा, यस.
ओके, सो दैट ट्रू फॉर डिफरेंशियल एज वेल.
दैट इज व्हाट?
उसमें भी ऐसे डिफरेंशियल इक्वेशंस में भी मतलब increasing decreasing का काफी बोला होता है, उसमें भी यही है.
So you do it through plus and minus only. That's the only way that you can distinguish between increasing and decreasing. Plus minus.
Okay sir.
Okay. And then फिर ये होगा, फिर end में ना सवाल आपसे ये भी पूछेगा कि find the rate of change, and then it might add another question where it says कि whether it's increasing or decreasing. So you decide that through the sign.
ठीक है sir. Thank you.
You're welcome. Alright, so we have a question on functions, then we have another question on integration, and then we have an equation of circles question. Okay, so let's do this one question and then we'll take a break. In fact, we only have how many questions? We have 3 questions left. Okay, so let's do question number 10 and then we'll take like a 5-7 minute break. Okay. Alright, now let's see what this says. So this says the function f is defined by f of x equals to x plus k of x squared plus k upon x plus 2 for x is greater than 0. Okay. Given that the curve with equation y equals to f of x has stationary point when x equals to 2. So stationary point, what does that mean?
dy or dx is
That
equal to
means
0.
dy by dx equals to 0. Okay. So stationary point means dy by dx equals to 0. So first let's write this nicely in a way that we can easily differentiate it. X squared plus k, x minus 1 plus 2. So now that we differentiated, dy by dx is going to be equal to 2x minus k x to the power minus 2 plus 2. Okay, so this is going to be, let me make sure I haven't done anything wrong here. Okay, so if we set this equal to 0, let's see what happens. Dy by dx equals to 0. Now we have 2x minus k upon x square plus 2. Now we know what the value of x is, it's equal to 2, so let's plug that in. So 2
Sir, doesn't the
2 yeah,
you differentiate? Why is plus 2 still there?
yeah, that's an error. It's going to be plus 0. So 0
And sir, won't it be minus 2kx? Oh no, never mind.
no, it will be minus kx. Okay, so we have 2 times 2, which is equal to 4, minus k upon 2 square, which is 4. Okay, so 4 equals to k upon 4, which means k equals to 16. Perfect. Okay, so we found out the value of k. 3 marks. Okay, that's not bad. Then it says determine the nature of the stationary point. Okay, so we know what dy by dx is. Dy by dx is equal to 2x minus 16 upon x square. So that's what dy by dx is going to be equal to now. Dy by dx will be equal to 2x minus 16 upon x square. Yeah. So what we'll do now is we'll double differentiate it. So first let's write it nicely. Dy by dx equals to 2x minus 16 x to the power minus 2. So if we double differentiate it, let's see what you get. So you get dy by dx equals to 2 minus 16 into minus 2. So let's just make it positive 32 straight away. X to the power minus 3. So what do we get? We get 2 plus 32 upon x cubed. So what do you think will happen if I plug in d square y upon dx square? So what do you think will happen if I plug in 2 over here? Will I get a positive value or a negative value? If I plug in 2, will the entire expression be positive or negative?
Positive value.
It will be positive. So what does that tell you? Minimum or maximum?
Minimum point.
Yep, it's a minimum point. So there you go. Okay. Given that this is the only stationary point of the curve, find the range of f. Okay, so it's a minimum point and it's also a stationary point. Okay, so how will I find out the range? So if I know what the minimum point on the curve is, let's say the minimum point is 5. Okay, hypothetically speaking, let's say that the minimum point is 5. Okay, we don't know what that is, obviously we'll work it out. But if the minimum point on the curve is 5, can we determine the range?
Yes, sir.
What will it be?
Greater than 5. F
Yep,
of x
greater than
is
or
greater
equal to
than
5. Perfect. Okay, so we know that the minimum point occurs when x equals to 2. Okay, and now that we know what f of x is, given that we've worked out the value of k, so it's going to be x square plus 16 upon x plus 2. So x square plus 16 upon x plus 2. Okay, so we'll work out f of 2. So that would be 2 square plus 16 upon 2 plus 2. So 2 square is 4. 16 upon 2 is 8. 4 plus 8 is 12. 12 plus 2 is 14. So this 14 is now what? This 14 is the minimum point. That means, although it's not a quadratic curve, but if let's say you have a curve, any curve, which we know has a minimum point of, let's say, 14, then we know for sure that all the other points will be either 14 or greater than 14. Okay, in fact greater than 14, since we already know what the minimum point is. So the range of this function would be greater than or equal to 14. And there you go. That's it. That's your answer. Now, any questions?
So is x equals to 2 already given in the question?
Yeah, x equals to 2 was given. It says, given that the curve with equation y equals to f of x has a stationary point when x equals to 2. So this was already given. Okay. Alright, question number 11. So let's take a break. What do you guys suggest? Let's take a 10-minute break? Or do you guys want to complete the paper?
So complete the paper.
Okay, that's great. Let's complete the paper. What about the rest of you? Are we all on the same page that we're completing?
So how many questions are there?
We're left with 2 questions, 11 and 12. 11 would be a lengthy question. 12 doesn't seem like a lengthy question. O, A, B. tangent might be. Well, yeah, 12 is not a lengthy question. 11 is a lengthy question. So let's complete it. Okay, let's complete it. So here's question number 11. Let's see what it says. It says the diagram shows the line x equals to 5 upon 2. So that's going to be a vertical line. That's a no-brainer. Part of the curve y equals to half x plus 7 upon 10 minus 1 over x minus 2 to the power 1 upon 3. And the normal to the curve at the point a, 3 comma 6 upon 5. Okay. Find the x coordinate of the point where the normal to the curve meets the x-axis. Okay, so this is a 5-mark question. That means there's a lot of working that's involved. So before I can find out the point where the normal to the curve meets the x-axis, I need to first find out the equation of normal. Okay, so how will I find out the equation of normal? I will find out the equation of normal by first differentiating it. In fact, even before I differentiate it, let's first write it nicely. But in the meantime, let's talk about the journey. So first we'll differentiate it, okay, and then we'll plug in the value of x, which is 3. That will give me the gradient of tangent. How will I convert that into gradient of normal? What am I going to do?
So perpendicular.
Reciprocate in negative way.
Yep, negative reciprocal. So half plus 0 minus 1 upon 3 x minus 2 to the power minus 1 upon 3 minus 1. So that's minus 4 upon 3. Okay, 1 upon 3. Yeah. So there's no point in simplifying over here because at the end of the day, you have to plug in a value. So 1 upon 3 into x minus 2 to the power negative 4 upon 3. So plug in x equals to 3. Okay, so that's what I'm going to do now. Dy by dx. So the gradient of tangent would now be equal to, and I'm just going to plug it in as it is in the calculator so that I straight away end up with the final answer. X minus 2, that means 3 minus 2. In fact, okay, so don't need to do that. I just realized 3 minus 2 is going to be 1. 1 irrespective to the power is going to be 1. So at the end of the day, we're just doing half plus 1 upon 3. Okay. So half plus 1 upon 3. Let's work that out. Half plus 1 upon 3 is 5 upon 6. So that means the gradient of tangent is 5 upon 6. Okay. Now if the gradient of tangent is 5 upon 6, what would be the gradient of normal? Minus 6 by 5. And we have the point through which the curve is passing. The point at which we want to find out the equation of normal. That's 3 comma 6 upon 5. Yeah. So y minus 6 upon 5 equals to m, which means minus 6 upon 5 into x minus 3. Okay. Now again, since you just want the point at which the line cuts the x-axis, that means at this point y is equal to 0. So I'm not going to bother simplifying. I'll just replace y with 0. That means minus 6 upon 5 equals to minus 6 upon 5 into x minus 3. So minus 6 upon 5 and minus 6 upon 5 will eventually get cancelled out. Okay, and now we're looking at minus 1. In fact, not minus 1, plus 1, because the minus will also cancel out. 1 equals to x minus 3, and then if you take the minus 3 over to the other side, so x equals to 4. Okay, so that means the point, okay, we don't have to give the point, we only have to give the x coordinate. So there you go. This is your final answer. Okay, so we didn't have to find out the equation of normal. We kind of did, okay, but since we only had to plug in a value, so there was no point in simplifying and giving it like a proper equation. Okay, now part B, which says find the area of the shaded region, giving an answer corrected 2 decimal places. So before I can find out the area of shaded region, let's take a screenshot of this.
Sir, could you show me the whole question, the part A solved?
There you go. Here it is.
Oh, push step 9.
In fact, you don't need the entire question. Okay, now. So we have to find out the area of shaded region. So let's first decide theoretically what is it that we're going to do. So what do you guys suggest?
Sir, integrate the curve with the limits pi by 2.
Okay, yeah, of course we'll integrate it. Okay, so like you said, integrate the
Say curve.
Curve within the limits?
Say 3 and pi by 2. And
3
then add
and
the area
5
of
by 2.
triangle.
Okay, and then we'll add the area of triangle. Yep, that's correct. Okay, so let's write that down over here. So we'll integrate y. So since there's not enough space, I'll just write y over here within the limits 3 and 5 by 2, which is 2.5, or you can write it as 5 by 2, whatever it is. Okay, plus the area of triangle. Now the question was nice in a way that it made us work out everything in advance. So we have this 3, sorry, not 3, this is 4. This point is 4, this point is 3. We know what the height is going to be. Okay, since we know what the y coordinate is, we know that the height of the triangle is going to be 6 upon 5. Okay, so the 6 marks that you're getting over here is obviously not for the area of triangle, it's for integrating and plugging in limits. Okay, so what I'll do is let's just work out the area of triangle first, since it's easy. So half into the base, what's the base going to be? The base is going to be 1 into the height, which is 6 upon 5. Okay, so 6 upon 5 into 2 is 10. So 0.6 or 6, whatever you want to write it. Unit square or square units. Okay, now let's focus on the area under the curve, which as we saw, for which as we saw we need to integrate the equation half x plus 7 upon 10 minus, now shift this in the numerator, x minus 2 to the power minus 1 upon 3 within the limits 3 and 2.5 or 5 by 2. Okay, so the integral of half x will be half x square divided by 2, so might as well just write it as 1 upon 4x square. Okay, to save some time there. So 1 upon 4x square plus 7 upon 10x. Okay, and this, if you integrate, you get x minus 2 to the power minus 1 upon 3 plus 1. Minus 1 upon 3 plus 1 is 2 upon 3. Let me just double check. Minus 1 divided by 3 plus 1 is 2 upon 3. Okay, now before I plug in the limits, it's a good idea that we simplify it. So this becomes 1 upon 4x square plus 7 upon 10x. So the x should have been in the numerator, not in the denominator. Okay, and minus 1, when you divide it by 2 upon 3, it becomes 3 upon 2. So minus 3 upon 2 within x to the power, x minus 2 to the power 2 upon 3 within the limits 3 and 2.5 or 5 upon 2. Okay, now we need to plug in the values. Okay, so be extremely careful when you're plugging in values. The upper limit, so I'm just going to use the calculator over here to save some time. Okay, I mean, I will plug in 3 as it is in this. So 1 upon 4, 1, and then you can just write down the answer with the upper limit plugged in and then the answer with the lower limit plugged in. So 1 upon 4, 3 squared plus 7 upon 10, 7 upon 10 into 3 minus 3 upon 2 into 3 minus 2. Although 3 minus 2 is going to be equal to 1, so I can completely ignore that, but the reason why I'm doing it is so that it's easy for me to later on plug in the lower limit. Okay, once you make the expression in your calculator, it becomes easy. 2 upon 3. Okay, so here's what I'm looking at. I'm looking at 57 upon 20. Okay, 57 upon 20 is with the upper limit plugged in. Now wherever I've plugged in 3, I'm going to replace that with 2.5. So 2.5, 2.5, and again wherever I've plugged in 3, I'll replace it with 2.5. So here's what I'm looking at. I'm looking at 2.3675. Again, since it's not the final answer, that's why I'm taking it. That's why I'm taking these decimal places. Okay, now we get to the final answer. So 57 upon 20 minus the last answer that I got. So we're looking at 0.4824 plus the area of triangle, which we worked out earlier, which was 0.6. Okay, so plus 0.6 gives us 1.08. So 1.08 square units is your final answer. Now, here's everything that I've done. Let me know if you have any questions.
So how do you find the values of the triangle on the x-axis, like 3 and 4? Like, how do you find 4?
We did that in part A. See, what did we do in part A? This line that you're looking at is the normal to the curve, and we had to find out at which point the normal line is cutting the x-axis.
Okay, sir.
Okay. Alright, now let's do the last question, which is find the area of the shaded region. No, wait a minute. It's the equation of circle question. So it says the diagram shows the circle with the equation so and so, x squared plus y squared minus 6x plus 4y minus 27 equals to 0, and the tangent to the circle at the point P 5, 4. Okay, so we have the coordinates of P. Might as well write that down. So this point is 5, and this point is 4. Okay, then it says the tangent to the circle at P meets the x-axis at A and the y-axis at B. Find the area of triangle OAB, where O is the origin. Okay, now before I can find out the area of the triangle, what do you think I need to find out first?
Say the coordinates of B and A.
The coordinates of B and A. For which, what do you think I need to find out first?
Say the equation of BPA line.
The equation of the line. Okay, now if I want to find out the equation of the line, I already have a point on the line. What else do I need in order to find the equation?
Find the
The center of circle.
Why? You're
Why
right.
they are perpendicular.
Yes, perfect. Okay, so that means basically I need to find out. So the thought process here is this: that okay, you need to find out the area. Fine. That means you need the coordinates of A, you need the coordinates of B. Okay, if you need the coordinates of A and B, that means you need the equation of the line. Okay, if you need the equation of the line, that means you need a point and the gradient. Do we have a point? Yes. Check. Do we have the gradient? No, we don't. So in order to find out the gradient, we don't have enough values, but if I can somehow find out the gradient of the radius, and then I can take the negative reciprocal of it, okay, that would give me the gradient of the tangent line. Alright, now x square, that means what do we have to do in order to find out the coordinates of the center?
Say completing square.
Yep, completing square. Okay, completing square, that means we're gonna add 3 square over here, that means we're gonna add 3 square over here, then we're gonna add 2 square over here, that means we're gonna add 2 square over here as well. Okay, now let's go back to red. X minus 3 the whole thing square plus y plus 2 the whole thing square equals to, although the radius is kind of unnecessary over here, but let's work it out while we're at it. Might need it later on, so it's 40. So what are the coordinates of the center?
Say 3 minus 2.
3 comma minus 2. So that means it's approximately somewhere over here. So now we will find out, let's call this point C. Let's find out the gradient of PC, which is going to be 6, since, not 6 actually, 4 minus minus 2. So here are the coordinates of P over 5 minus 3. So 4 minus minus 2 is 6, 5 minus 3 is 2, 6 upon 2 is equals to 3. So the gradient of the radius is 3, that means the gradient of the tangent is going to be minus 1 upon 3. And we have the coordinates 5 comma 4. Let's put it together. Y minus 4 equals to minus 1 upon 3 into x minus 5. That means 3y minus 12 equals to minus x plus 5. Okay, well, since we have to plug in the values, so might as well write down the equation of the tangent. So this is the equation of tangent. Okay, 3y plus x equals to 17. So if I want to find out the coordinates of A, the coordinates of A will be x comma 0. Okay, so that means y is 0 and x equals to 17. So the coordinates of A are 17 and 0. Okay, and the coordinates of B, you can do that over here. Do we have enough space? Okay, no we don't, so let's do it over here. For the coordinates of B, we'll have 0 comma y, so that means you'll plug in 3y plus 0 equals to 17, which means y is equals to 17 upon 3. So this is the final stretch now. Area of triangle OAB is going to be equal to half into base into height. Now since one point is the origin, that means whatever the coordinates of A are naturally becomes your base. Whatever the y coordinate of B is, that will naturally become your height, and the other way around, doesn't matter. So half into 17 upon 3 into 17 is what we have to do at the end of the day. So 17 squared is what? 289. 17 into 17, 289 divided by 6. So 289 divided by 6 square units is your final answer. So, any questions? Okay. Now, then it says points Q and R also lie on the circle such that PQR is an equilateral triangle. Okay, so what I would prefer is. Sorry?
So can you show me the B's work?
So basically B is 0 comma y, so you plug in 0 in place of x in this equation, solve for the value of y, you get 17 upon 3. Okay?
Yeah, sure.
Alright, now. Okay, so here it is. Find the exact area of triangle PQR. So area of triangle PQR. So we have the coordinates of the center, okay, and not only that, we in fact also have the radius. So we have to find out the area of triangle PQ and R. Okay, so first let's actually make a triangle. Okay, now what we have to do is, if I can sort of divide this triangle, I can divide this triangle into 3, okay, and all 3 of them will be equal. Okay, now if all 3 triangles are equal, what do you think will be the angle in one triangle?
120.
120. Why 120? 360 divided by 3, which is equal to 120 degrees. So here is under root 40, here also is under root 40, and here also is under root 40. Okay, so we have the angle, we have the length. How will I find out the area of the entire triangle? What am I going to do?
Half AB sin C.
Half AB sin C, and then is that it? Half into under root 40
No, sir, multiply by 3.
into under root 40 into sine 120. Okay, and then don't forget to multiply it by 3. Okay, and make sure to write it down what you're doing. It's a 3-mark question, so you will say that area of triangle PQR is equal to 3 times the area of triangle CPQ, and since C is a point that we ourselves have labeled it, okay, and so make sure to write it down where C is, where C is the center of circle. Okay, and also write down that the radius is equals to under root 40. Okay, so now that's it. 3 upon 2 into 40 into sine 120. Now my calculator was in radian mode, and if you're doing alongside, I'm sure yours would also be in radian mode, so make sure to convert it back into degree mode. Okay, so if you work this out, 2 1s are, 2 20s are, 2 1s are, 2 10s are, 10 into 3 is 30, 30 under root 3 square units is your final answer. So there you go, that's it, that's your answer. And that's the end of the paper as well. So any questions, anything that's not clear, please feel free to ask.